Okay, so today we're going to talk about the two parts. So the first part is about the complex number. Okay, the second part is about solve. Second order differential or differential equation of second order equations. Okay, so let's first talk about the complex number. So first you have to know this one. So it's kind of EI theta is cosine theta plus I sine theta. So this is called the, I think last time I talked about this, all in a formula. So, and then you have to know the geometric meaning of this. So EI theta, so this is EI, this is theta. So, and then this is EI theta, it's cosine theta plus I theta. If you think this is x-axis, this is y multiplied by I, this is x. So the coordinate is kind of cosine theta, sine theta. So you know, this is kind of called the polar coordinate. Anyway, just a name. If you, maybe some of you know it. If you didn't know this, just say, okay, this is kind of polar coordinate. So cosine theta, yr sine theta, like this. But x squared plus y squared is 1. So means that EI theta stands for the point on the unit circle. Okay, unit circle. And also, in general, the problem is unlike this. For example, I give you 1 point is A plus BI. How do we convert it into EI theta and a number? So the method is fixed. So first, you make your A, because you don't know what's A and B. The method is like this. You write it in this form. This is, okay, how? A squared plus B squared. Okay, and then A over A squared plus B squared plus B and A squared plus B squared, like this. And then you can write this is A squared plus B squared is EI theta. So what's theta? Cosine theta is A over A squared plus B squared. Or sine theta. If this is right, the technique should be, you have to consider two, because you know you don't know where is the theta, maybe in the first, second, third, or third quadrant. You don't know. You have to check both. Okay, and then you can write your this form left hand term into the complex, this kind of argument case. Okay, so you have to practice this part, and it's very important. Okay, so the second part is about, so this is part 1 and part 2. A lot of problems related to this in this worksheet today. So let's solve equations. I think last time I talked about differential equation of second order like this. X dual derivative or y is the same plus b y plus c is 0. Be careful, this is 0. A, B, C are constants. If it's not a constant, no, we are not studied in our class. So, but I know, and then the method is like this. You first consider the character, this is also called the all-in method. You consider the characteristics equation. This is A lambda squared plus B lambda plus C is 0. You can solve lambda 1, lambda 2, includes complex number. Okay, if lambda 1, lambda 2 are real, and lambda 1 is not lambda 2, lambda 1, lambda 2 is real, lambda 1 is lambda 2, 3, lambda 2, 1, lambda 2 are non-real. If it's this case, the solution should be like C1 lambda 1x plus C2 lambda 2x. For the second case, this is C1 lambda x. You write it as lambda because lambda 1 is equal to lambda 2, right? And this is lambda 2 lambda 2x. Okay, so if this is real, if this is non-real, you write lambda is a plus bi, lambda 2 is a minus bi. It should be this. Okay, I think all of you know this. And then the y-x should be what? EAX C1 cosine BX plus C2 sine BX. It's kind of, the method is very standard, right? You don't have to, rethink it by yourself. Just, just look at problem and check what happened. Which case would be happen? Okay, but for this case, this is only homogeneous case, right? We already talked about this last time, but today the problem should be like this. So if after we know, okay, if you want to solve an equation like this, oh sorry, just another new, unknown number. Okay, C is 0 and this is F. So this is a non-homogeneous case. Okay, this is already know is A, this is B. For this case, how do we know? So first, we have to know how do we solve this equation. The method is like this. You first find the solution for the homogeneous equation, right? You find y1 and y2 like you do it for the linear equation. And then the second step, you find a particular solution for the star, just right? And then the solution should be y equal to yp plus c1 plus this plus c2 y2. So that's the method. Or we already knew how to find the solution for the homogeneous case, right? So what we do is, how do we find the particular solution? In general, if f is bad or arbitrary function, I don't know. I think nobody knows. If f is very complicated, but for our class, where in general f is good, or just some polynomial or some exponential function, cosine or trigonometric function. For that case, we know. For example, I will tell you some case you should remember it. Okay. For example, if f is a polynomial, case 1, it's kind of a, for example, a(n)(xn) plus a(1x) plus a0. For this case, we know the particular solution should be like this. Should be like a(n)(xn) and a(1x) plus a0. Okay. Okay, anyway, you have to be careful. Okay. Anyway, this case is okay. Okay. And then you plug in this YP into star and try to determine A0. Okay, this is the first case. The second case is if f is kind of like this, cosine AX or sine AX, or the combination of sine and cosine, or like a sine, for example, for this case. So you have this solution, YP should be like a is the one, like A1 cosine AX plus A2 sine AX. Even you f is only cosine, you have to assume the YP in this form, because you don't know what's YP. You have to know. Maybe sometimes you get, okay, Y2 is 0. nobody knows for the specific problems. Okay, this is kind of this kind of case. So let's move. Okay, okay. I want to stay in the same page. The case 3, if the f is EAX. Sorry, the problem. Sorry, a bar, a bar, a bar. This a is has no relation with the ABC in this equation. Okay, a bar like this. So if it's like this, you have to assume the solution yp is EAX and A1 and try to determine A1. But for this case, you have to be careful if sometimes your A bar is equal to, for special case, is equal to, your lambda 1 or lambda 2, lambda 1 or lambda 2. For this case, you have to assume yp is A1 depend, depends on what's the multiplicity of lambda 1. If the multiplicity of, if lambda 1 is lambda 2, you have to assume the solution is like this. If lambda 1 is lambda 2, so if for this case, it's kind of your A bar is not equal to lambda 1 and is not equal to lambda 2. So if A bar is equal to lambda 1 and lambda 2, if lambda 1 is equal to lambda 2, there should be 2 because the multiplicity is 2. This should be A1x A lambda x if lambda 1 is not lambda 2. Okay. Okay, anyway, you cannot just, listen to what I said here and memorize. Oh, you have to meet all kinds of problems. And then, okay, after you do this problem, I think you can memorize it. So that's what I want to say today. So if you have any question, so you can ask me now.